Podcast number 6, prove that sine squared plus cosine squared is equal to 1. So this is pretty amazing. You can take whatever angle you want, pick a number. All right, 33. And I go sine 33 and then square it. So when we write it on paper, the square goes right there, but the calculator can't do that, so it puts it right there at the end, but it means the same thing. Plus cosine of 33 and square it. And the answer is 1. Sine of 12.4, square that, plus cosine 12.4, square that, equals 1. So no matter what you put in there, as long as you put the same thing, it equals 1. And now to prove it. So I'll use this little right triangle, and I'm going to call the sides X, Y, and R. You could call them A, B, and C, or whatever you want, as long as you use 3 different letters. Now, I'm going to use the definition of sine. So sine is equal to, sine is opposite over hypotenuse. So this is the opposite, this is the hypotenuse. So it's y over r. Cosine is equal to adjacent over hypotenuse. So it's x over r. Now this was the setup for my proof, but my proof is actually going to go like this. So I start with one side, sine squared theta plus cosine squared theta. Then what does that equal? So sine is equal to y over r. And that means that sine squared is y over r squared. Cosine is going to be this x over r squared. Then when you square a fraction, that means you square the numerator and square the denominator. So this one is y squared over r squared. This one is x squared over r squared. And what's the rule for adding 2 fractions? They have to have the same denominator. And these already do. So you can combine this and make one fraction, x, oops, I was going to say y first. I guess because it's addition, the order doesn't matter. X squared plus y squared, or y squared plus x squared. My brain is used to going in alphabetical order. Okay, now why does this equal 1? Well, if you look at this triangle, you can do the Pythagorean Theorem, and r squared, if you do the Pythagorean Theorem, the hypotenuse squared equals this squared plus this squared. So this x squared plus y squared can be replaced with r squared from the Pythagorean Theorem. And then we're just left with r squared over r squared, which equals 1, and that is the end of the proof.